Good morning. So yesterday we discussed 2014 paper. In the 2014 paper, the M.C.Q sections we start. And then in today's section, we have to consider 2014 paper, other M.C.Qs. I guess I have done only one question, right? So the question was in 2014 paper, question number 5. Which of the following is equivalent to the decimal value 131 base 10? Right? That question is already done. Today we have to start discussing question number 6, 7, 8, and 9. Right? Okay. So I will continue the discussion. (2014) paper, question number 6, right? So 2014 part 1, question number 6. Right? The question is, what is the decimal equivalent of binary number 101011 base 2? Right? So the decimal equivalent of the binary number 101011 base 2. So 101011 base 2. You have to multiply it by 2 to the powers. 2 to the power 0, 1, 2, 3, 4, 5. So we can remove this one and this one. So 1 plus 2 plus 8 plus 32. So altogether it will be 43. So for the question number 6, the answer option will be third answer option. Right? So third answer option is your answer. That is 2014 part 1 question number 6. Now we will consider question number 7. Question number 7, which of the following has the least value? Right? So you are going to find out the least value. You can see there are binary number, decimal number, octal number, and hexadecimal number. So we have to write each and every answer options. The first answer option is 1100 1001 base 2. Second answer option is 145 base 10. Third answer option is 77 base 8. And the fourth answer option is 49 base 16. Right? So here, this is in binary, this is in decimal, this is in octal, this is in hexadecimal. So this is a small numbers. So these are the small numbers. You can convert the numbers into decimal. That is very easy. Right? So what I am going to do is I am going to convert the numbers into decimal. So in this case, When I convert 11001001, when you are having an M.C.Q question, right? Listen carefully. When it is an M.C.Q question, no need to multiply it by 2 to the powers. Straight away write 1, 2, 4, 8, 16, 32, 64, 128, right? To the powers. So when I add 128 plus 64, that will be 192 plus 8, 200, 201. Right? The question is least value. So I can eliminate the first answer option. This one is 8 to the power 0. This is 8 to the power 1. 1 into 7, 7 plus 8 into 7, 56. 56 plus 7, it is 63. So I can remove second answer option. 49 base 16, 16 to the power 0, 1. Okay. So 16 to the power 0, 16 to the power 1. 1 into 9, 9 plus 16 into 4, 64. So altogether, it will be 73. So 63, 73. Remove this one. Third answer option. Right. That is your answer for the question number 7. Right. So question number 7 is done. Now I will do the question number 8. Right. 2014 part 1 question number 8. Question number 8. Which of the following has the highest file size? Right. So highest file size we have to consider. .doc file of 1 megabyte. So first one 1 MB. Right. The size will not be depend on the file type. Right. You can ignore the file type. Don't consider the file type. So we can straight away consider the measurement units only. So in this case, 1 MB. Second one, 912 KB. Right? 912 KB. Third one, 700 bytes. And the fourth one, 1024 bytes. 1024 bytes. Right? So these are the options. They ask you the highest file size. Right? So here both units are in bytes. This is 700, this is 1024. So this is the least one. I will remove this one. This is in bytes. Here megabyte, kilobyte, byte. So the order is byte, kilobyte, megabyte. Right? So when you consider 1 kilobyte, it will be equal to 1024 bytes, right? So here it is 1024 bytes. It will be how many? 1 KB. Here we have 912 KB. So this is equal to 1 KB. So I can remove because it is 912 KB. Here it is 1 KB. So I remove this one. Then when you consider kilobyte and megabyte relationship, 1 megabyte will be equal to 1024 KB. Here I have 912 KB only. This is 1 MB. So this one is the larger one. So the answer option will be first answer option. Right? So that's the end of 2014 paper, question number 8. 2014 paper, question number 9. But again and again they will ask in the ASCII section. But so in the ASCII section, question number 9 is if the character capital E is represented, right? So there's a comparison. So I will write that. Right? Question number 9. The question number 9 is if the character capital E is represented as 1000101. So capital E will be denoted by 1000101 base 2 in ASCII. What is the ASCII code for character capital B? Right. So they ask you the capital B, what is the code? So we already studied that the order is capital A to capital Z. There will be one value increase. So this is E, this is B. So when we consider the position, B will be here, E will be here. Right? So E is greater than B. But the given value is E. This is B. So you have to subtract certain numbers to find out B. So when I have the order A, B, C, D, E, you are going to find B. 1, 2, 3 steps. So you have to subtract 3 from E in order to find out the value of B. So initially I will convert number 3 into binary format. When I do the conversion, it will be 1 1 base 2. Right? 1 1 base 2 will be your answer. So you have to subtract 1 1 base 2 from this value, from the value E, in order to find out B. So 1 minus 1, it is 0. When you borrow 1, it will be 2 ones. 1 minus 1, this 1 will be here. This one will be 0. Others 0, 1. So the value of B will be 1 0 0 0 0 1 0 base 2. In your answer options, 1 0 0 0 0 1 0 base 2, second answer option. Right? So that's the end of 2014 paper, part 1 questions. The questions are from question number 5 to question number 9. Right? That's the end of that chapter. Now we will move on to the 2014 paper, part 2 questions. In part 2 questions, there are few questions there. In question number 1, as usual in the compulsory section, question number 1, part 5. Okay. So now we will move on to the part 2 questions of 2014 paper. In 2014 paper, in part 2, question number 1, the part 5 is your first question. Convert the hexadecimal number A7B. A7B. Base 16 into its equivalent binary number. Show your computation. Right. So you're going to convert the hexadecimal number into binary number, which means base 16 to base 2. It is 2 to the power 4. This is 2 to the power 1. Right. So what you have to do is initially write down the each and every digits separately with some space. But by providing some space, you have to write. That is your first or initial step. Then what you have to do is you have to write the decimal equivalent of the letters. So B will be 11. This is 7. A will be 10. So all together you have to consider and then convert each and every values into the 4 digits binary number. So it will be 51, 21, 10, 0, 1. So the value will be 1101. When you convert number 7 divided by 2, it will be 31, 11, 0, 1. So 111 will be there. You have to put a 0 in front. When you convert number 10 divided by 2, it will be 50. Divided by 2, it will be 21. Divided by 2, it will be 10. Divided by 2, it will be 0, 1. So the 10 will be 10, 10. So here you have to write the converted binary digits 10, 10, 0, 111, 1101 base 2. Right? That is your answer for the question number 1, part 5 question of 2014 paper. Right? So for this step, you will have 1 mark, and for the final answer, you will have 1 mark. So altogether, you will get 2 marks. Right? So that's the end of 2014 paper, question number 1, part 5. There's another question. It is in 2014 paper, part 2, question number 1, part 6. Right? So the part 6 question is, encoding schemes are used to represent characters and symbols within the computer. List 2 different encoding schemes. So you can write EBCDIC, ASCII, Unicode. Any 2 options are correct. Right? So you can write EBCDIC, ASCII, Unicode. If you are writing two from these 3, that will be fine. So the answer will be EBCDIC, ASCII, Unicode, right, for the part 6. So when we consider the exam paper, part 1, we had 5 questions, 5 marks. Part 2, 2 major questions from question number 1, it will be 4 marks. So altogether 9 marks. Right? Nearly each and every year you will face 10% of your questions as compulsory from this unit. Right. So that's the end of 2014 paper. Now we will consider 2015 paper. Right. 2015 paper. Right. In 2015 paper, part 1, we had the questions from 5 to 8, sorry, 9. Right? Question number 5, 6, 7, 8, and 9. Right? There are 5 questions. We have to consider one by one. So the question number 5 of part 1, 2015 paper. Which of the following octal number is equivalent to decimal number 79? Right? So all the answers are in octal because they ask you the octal equivalent. So don't worry about that one. So straight away you can write 79 and then convert it into equivalent octal. Right? So here it will be 9 times 72 and the balance will be 7. 1 times 0, 1. So your answer will be 117 base 8. So 117 base 8. That is your first answer option. Right? First answer option. So that's the end of question number 5. Question number 6. It's a theoretical question. Which of the following formats are used in computers to store data? Which one? Binary number format. Right? So binary number format is your answer. So the question number 6, the answer will be first answer option, binary. Right? So that's the end of 6th question. Question number 7. Which of the following decimal numbers is equal to the binary number 110 base 2? Right? 110 base 2, question number 7. Right? 110 base 2. This is question number 7. Right? So they ask you the decimal equivalent. So what you have to do is you have to perform the decimal conversion. Right? So that is decimal conversion we have to perform. As I said earlier, this is an M.C.Q question. So don't write the 2 to the powers. Straight away write 1, 2, 4, dash means 8, 16, 32. So 32 plus 16, it will be 48. 48 plus 4, 52 plus 2, 54, 55. Right? This is the quickest way to find out the answer. The answer option will be first answer option, 55. So question number 5 also first answer option, 6 also first answer option, and now 7 also first answer option. Right? So that's the end of 2015 part 1, question number 7. Right? Now we will start discussing question number 8. Which of the following represents the ascending order of four numbers? So they gave you four numbers. You have to find out the ascending order. Right? So here the given numbers are 1,000,000, 1111, base 2, 170 base 8. There's a technique, right? That's why I'm going to explain it. Right? 46,687 base 10 and 2F base 16. Right? So they ask you the ascending order. So ascending order means smaller number to larger number. That is ascending order. Descending order means larger number to smaller number. So this is ascending order. But this is an very interesting question. And also there's a technique to find out the answer within few seconds. Right? By depending on the techniques, you can find out you can determine the answer very fast. Right? I will explain you. Right? So ascending order means you are going to order it from smaller to larger. Right? So first one is your smaller number and final one will be a larger number. Right? So I will compare all these numbers. The decimal equivalent is this one is 46,687. Right? So this one won't be this is your straightforward finding. When you consider this number 1, 2, 4, 8, 16, 32, 64, 128. Right? So this digit is 128. So the balance all must be less than 128. Right? These all digits. Right? So here it will be nearly 200 plus. Nearly. Right? Why? If all the digits are 1, the value will be 127. So 127 plus 128, it will be nearly 200 plus 250 likewise. So here definitely this is not from the beginning or the end. Why? This is in middle. This one is the largest one than this one. Then you have these two. Right? So when you find out this one and this one, you can determine the answer. 170 base 8. So this is 8 to the power 0. This is 8 to the power 1. This is 8 to the power 2. So when you consider this conversion, you can remove this one. 8 into 7, 56. 64. Right? So altogether 64 plus 56, it will be 120. Right? So this is 120. This is 200 plus. This is 46,000 only. Right? When you convert this one to F, 16 to the power 0, 16 to the power 1. 1 into 15, 15. 16 into 2, 32. So 32 plus 15, it will be 47. Right? So 47 120. This one is 128 plus. Why? This one is 128. This one is 46,687. So never do the calculation here. So you can determine this is the lowest value. When you consider the lowest value, there will be only one answer option is the third answer option. Right? 2f base 16, 170 base 8, 1,000,011,11 base 2, 46,687 base 10. Right? So never do the calculation like this. You can write like 128 plus. If you really want, you can perform. Otherwise, don't do this. Right? So that's your question number 8 of 2015 paper. Now we will consider question number 9 of 2015 paper, part 1. Right? So in part 1, question number 9. Which of the file or files given in the table 1 could be stored in a USB storage device having a total capacity of 4 GB so that a least amount of unused space is left on the device? Right? So the summary of the question is, you are having a flash memory with 4 GB. Right? There are 3 files. File A is 300 MB. File B is 740 MB. File C is 3 GB. Right? But your condition is, you have to keep least amount of unused space. Right? From here, the least amount of unused space will be your balance. Right? So here it is 300 MB, this is 740. Nearly altogether it is 1 GB, nearly, not exact, nearly. Right? But it is more than 1 GB. So here, initially I will put 3 GB file here. When I put 3 GB file, there will be 1 GB balance. So 1 GB will be equal to 1024 MB. This is 740, this is 300. So first provide 740. So I am going to put file B. So when I subtract this one, 4 minus 0, it is 4. Here it will be 12 minus 4, it is 8. And then you will have 2. 284 MB is your balance. But I have 300 MB. So we can't put A. So the best answer option is B and C. Right? So B and C only, second answer option. Right? Always consider 1 GB is equal to 1024 MB. Right? So you have to do that type of conversion. Now we will consider 2015 paper, part 2 question. In part 2, there are 2 questions, part 5 and part 6 of question number 1. So 2015 part 2, question number 1, part 5. Right? Convert the binary number 1101001 base 2 into equivalent octal number. Show your steps. Right? So they gave you the binary number 110 101 01 base 2. So we are going to perform the binary to octal conversion. Right? So this is the part 2 question. So you have to write each and every steps and determine the answer. So here I will write the number with some space 110 101 01 likewise. The octal conversion 2 to the power 1 to 2 to the power 3. So I have to create groups from right to left, 3 digits groups. So there are 3 groups. So you have to multiply it by 2 to the powers. This is part 2 question. So you have to write. No any options. 1, 2 to the power 2, 2 to the power 0, 2 to the power 1. Right? 110 101 01. Right. So when I multiply it by 1, this is 1 plus 0 plus 4. This is 0 plus 2 plus 0. Why? We can remove these things. 1 plus 2. So here it will be 3. This is 2. This is 5. So 3 plus 2 it is here 3, 2, 5 base 8. Don't write it below. You have to write it nearby here. It will be 3, 2, 5 base 8. For this step, you will have 1 mark. For this step, you will have 1 mark. Altogether, 2 marks. Right. So that's your 2015 paper, part 2 question. Question number 1, part 5. In the same paper, part 6 is there. Again, it's an ASCII conversion. Right? So in M.C.Q second part, always there will be a ASCII conversion question. Right? Most of the time, 90% of the time, they are asking a conversion, a simple conversion in ASCII. Right? So this is your final question of 2015 paper. So 2015 paper, in the question is, in the ASCII code, the letter capital A is represented as decimal 65. Determine the binary representation of letter D. Right? So A is having the decimal equivalent of 55. They ask you the binary equivalent representation of letter D. Right? But the question is in ASCII. Right? So when the question is in ASCII, you have to convert it in 7-bit binary format. Right? So A they gave, you have to find D. So A, B, C, D, it will be 3. So you have to add 3. So write down A 65 plus 3. So D equal 68. But this is not your answer. They ask you the binary representation. So what you have to do is D equal. Then write 68 and convert it into 7-bit binary value. It is 81 40, 20, 10, 01. So your answer will be 1 triple 0 1 0 0 base 2. Right? 62 plus 4. So 64 plus 4, 68. Right? So this is your answer. You will have half mark here. For this one, half mark. For the final step, you will have 1 mark. So altogether, you will have 2 marks. As I said earlier, in 2015 paper, part 1 is having 5 M.C.Qs, so 5 marks. Part 2 is having 2 parts, which is 4 marks. Totally 9 marks, which is 9% right, of your final paper. So that's the end of 2015 paper, part 1 and part 2 questions. Right. Now we will start discussing 2016 paper. Right. In 2016 paper, right. So 2016 paper, we will start discussing. In 2016 paper, I will start part 1 questions. In 2016 paper, part 1, question number 4, 5 is there. And also later on we will have questions 33 and 34. Right. So 2016 paper, part 1, question number 4. Which of the following is approximately equivalent to the 1 terabyte? Right. So they told you the approximately equivalent to. And when you consider the answers are in base 10, not in base 2. Right. So 1 into 1 terabyte they asked. They asked the approximate value of as 10 to the power 6 MB, 10 to the power 6 GB, 10 to the power 6 KB, 10 to the power 9 bytes. So when you have the answer option in base 10, what it means is they are not getting 1024. They are considering 1000. So 1000 will be equal to 10 to the power 3. Right? That's what they are going to consider. So when I consider these all units, byte is there, kilobyte, megabyte, gigabyte. The given value is terabyte. Right? So here GB is there, MB is there, KB is there, bytes is there. So 1 terabyte, this is the larger unit. When you convert it into gigabyte, usually we will multiply it by 1024. But in this case, we will perform 1000. So 1 TB will be equal to 1 into 10 to the power 3 GB. So this is wrong. When we convert it further, again multiply it by 1024. In this case, we will multiply it by 1000, which means 1 into 10 to the power 3 into 10 to the power 3, which means 1 into 10 to the power 6 MB. Here, 1 into 10 to the power 6 MB is there. So the answer option is first answer option. Right? So you have to consider when they ask you to consider as approximately, we will never consider 1024, we will consider 1000 and say it is 10 to the power 3. Right? That's the answer for this question number 4. The answer option will be first answer option. Now we will consider 2016. Part 1, question number 5. Right? So part 1, question number 5. The question is, what is the decimal equivalent of the octal 64? So they gave you the octal number and asked you to convert it to decimal. Octal to decimal conversion. So 64 base 8, you have to multiply it by 8 to the powers, 8 to the power 0, 8 to the power 1. 1 into 4, 4, plus 8 into 6, 48. So 48 plus 4, 52. So the answer option will be second answer option. Right? That is your 16 paper, question number 5 of part 1. Right?